In this lesson, we will focus on what the function does as x approaches infinity and also as x approaches negative infinity. We will find the horizontal or oblique asymptotes for each problem. Let's consider the function 2x minus 3 over x squared plus 3x plus 1. Since the numerator and the denominator are not factorable, we cannot transform this into graphing form like we did yesterday. Because the numerator is smaller than the denominator, we're also not going to divide like we did yesterday. Since we're only concerned with large values of x, we can determine the long-run behavior by taking the ratio of the leading terms. So the leading term on top is 2x. The leading term on the bottom is x squared. I'm going to take the ratio of just these two numbers. So 2x over x squared will reduce to 2 over x. So this function behaves like a 1 over x function. As x approaches positive infinity, you'll notice that the function is above y equals 0. And as x approaches negative infinity, you'll notice that the function lies right below y equals 0. Notice that my asymptote is still at y equals 0. That did not change. So we're going to write our end behavior as such. As x goes off to infinity, the y values stay right above the 0 on the right. As x approaches negative infinity, as we move to the left, the y values are going to be right below y equals 0. So when we're above y equals 0, I put a little plus. On the side where I'm below y equals 0, we put a little minus. This is called looking at the long-run behavior. Notice I'm not looking at the vertical asymptotes. We're only looking left to right. Okay, let's look at another problem. So this next problem has x plus 3 over x squared times x plus 1. In order to find the end behavior of this, the first thing we need to do is FOIL. So if we were to FOIL, we would have x plus 3 over x to the third minus 3x squared plus 4. Again, factoring doesn't help, dividing doesn't work, so we're going to take the ratio of the leading coefficients again. So I'm going to have x over x plus x to the third. If I reduce x over x to the third, I get 1 over x squared. So let's review. 1 over x squared looked a lot like this. This is the one I called the volcano. So it's going to resemble this function. It's still going to have an asymptote at y equals 0. As we go off to positive infinity, I'm going to be above the y equals 0. As we go off to negative infinity, I'm going to be above the y equals 0. So the behavior statement would read like this. As x approaches infinity, y is above y equals 0. As x approaches negative infinity, the y values are still above y equals 0. So this isn't too bad. You're just looking at the leading coefficients and looking at, does it look like 1 over x, or does it look like 1 over x squared? Let's go take a peek at another one. On this one, there's a little bit more going on. We've got 3x squared plus 5x minus 6, and then we got x squared plus x minus 1. On this one, we're not necessarily going to look at the ratio of them. What I'm going to go do instead, because they're the same, is I'm going to go divide. I've got an x squared over x squared. So I'm going to divide x squared plus x minus 1 into 3x squared plus 5x minus 1 like we did yesterday. So when we've got the same exponent right here, we're going to go ahead and divide. So we're going to divide, and if I divide x squared into 3x squared, it goes 3 times. 3 times x squared is 3x squared. 3 times x is 3x. 3 times negative 1 is negative 3. And then just like we did the other day, we're going to subtract. These will cancel. 5 take away 3 is going to give me 2. Negative 6 minus a negative 3 is like negative 6 plus 3, which is minus 3. Remember, this is my remainder, and your remainder is what goes on top of what you divided by. So I've got 2x minus 3 over x squared plus x minus 1. And this number up top is what we're going to plus. And I like to write it like this, actually. I prefer to write this first. So now you notice that it's bigger on bottom, so we're going to take the ratio again, just like we did earlier. So this right here is going to reduce into 2 over x plus 3. So this one is going to look a lot like the first one that we did, except that now I'm going to have an asymptote at 3, not at 0. So notice that I came up here to 1, 2, 3. It's still 2 over x, which is just like 1 over x. So the right side is going to be above the horizontal asymptote, and the left side is going to be below the horizontal asymptote. So on the right, as x goes off to infinity, my function is going to be above 3, so we put a little plus. And as x goes off to the left, to negative infinity, we're going to be below the horizontal asymptote. So I'm going to put a 3 with a negative, stating that I'm going to go below. Okay, the last problem we're going to do is a little bit trickier, and we've never seen one like this before. They want me to find the end behavior of x to the third plus x squared plus 4 over x squared minus 3. We're going to do long division again, and we haven't done one like this in a while. So how many times will x squared go into x to the third? It'll go x times, because x squared times x is x to the third. So I'm going to multiply this. X times x squared is x to the third. X times negative 3 is negative 3x. We're going to go subtract. The x squared comes down. I have no x's here. Minus a negative 3x is plus 3x. And then I bring down my 4. Now how many times will x squared go into x squared? It goes 1 time. Then we multiply by 1. 1 times x squared is x squared. 1 times negative 3 is negative 3. And then we subtract. The x squareds cancel. The 3x comes down. 4 minus a negative 3 is 3x plus 7. And now here's the new piece. On this one, notice that, again, I like to put my remainder over what I divided by first. Now I can reduce, like what we did earlier today. But over here, I've got this weird thing. I've got this x plus 1, and we didn't do this yesterday. This is new. So the 3x over the x squared, that's going to reduce to 3 over x, which we know what that looks like. That's our reciprocal function. But this time, I've got a weird asymptote. It's not a horizontal line like what we're used to. This is actually called an oblique. And it's going to be the line x plus 1. So let's see what that's going to look like. So here's our equation that we just talked about. We looked at our coefficients, and it reduced to 3 over x. And then we've got this oblique asymptote. So we went and graphed the line. Y equals x plus 1. Starts on the 1, up 1, right 1, up 1, right 1. Because it's a positive 3 over x, it's still going to stay above the asymptote on the right and below the asymptote on the left, like it always has done. It just looks weird when you graph it. So we're going to say as x goes off to the right, we're going to be above my oblique asymptote. And as x goes off to the left, we're going to be below the oblique asymptote. So the next video that's going to follow is going to go through your worksheet long range behavior. I'm going to do a couple problems with you and then give you a couple to try on your own. All right, here we go.